So there was a question many students left blank on the homework last night, and there's really no reason for this. It's just midpoint and distance. So I just wanted to go over it today in time for the test tomorrow. So here we are given the vertices of triangle ABC are A, 2, 1, right here, B, 4, 8, and C, 6, negative 2. So I connected these points to get this triangle. And now I'm supposed to find the lengths of the three sides of the triangle. Okay, so in this question, I see the word length. So I know I need to use the distance formula. I'm going to erase this so I can have some extra room. All right, so first I'm going to find the length of AB. A is 2, 1. B is 4, 8. I'm going to do x1, y1, x2, y2, and I'm going to plug it into the distance formula. Okay, so I have distance equals x2 minus x1 squared plus y2 minus y1 squared. This is definitely going to be one of the formulas on the test, so you have to memorize it by tomorrow. So I'm going to just plug in my values. I have x2, which is 4, minus 2 squared plus 8 minus 1 squared. I have distance equals the square root of 2 squared plus 7 squared. I'm going to get distance equals the square root of 4 plus 49. Distance equals the square root of 53. Distance equals 7.28 units. So the length of AB is going to be 7.28 units. Okay, just so I can keep everything all together, I'm going to erase this and do the distance formula for the next side that I need to find, which is BC. I have B, which is 4, 8. And C, which is 6, negative 2. I have x1, y1, x2, y2. And I'm going to get the formula all set up right here. x2 minus x1 squared plus y2 minus y1 squared. Distance equals 6 minus 4 squared plus negative 2 minus 8 squared. Distance equals the square root of 2 squared plus negative 10 squared. Distance equals the square root of 104. Oops. Distance equals 10.19 units. And that is the length of BC. So BC is 10.19 units. I'm going to do that for the third and final side, which is AC. And that will be A is 2, 1, C is 6, negative 2. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. I'm going to label my stuff. And I'm going to get distance equals square root of 6 minus 2 squared plus negative 2 minus 1 squared. Distance equals the square root of 4 squared plus negative 3 squared. Distance equals the square root of 16 plus 9. Distance equals the square root of 20. 25 distance equals 5. So the length of AC is going to be 5 units, units, units. All right, so I have used the distance formula to find the lengths of the three sides of the triangle, and they are right over here. So we answered part A, which was graph the points, and part B, which was find the lengths of each side. Now, let me just rewrite my lengths. Hold on just a moment. I have A, B, A, C, B, C, BC is 10.19, AC is 5, AB is 7.28. Okay, so now we are on to the other part B. I think the question was mislabeled, but it says find the coordinates of the midpoints of each side of the triangle and write them. Call E the midpoint of AB. Okay, so E is the midpoint of AB. F is the midpoint of BC. I'm just eyeballing it. I don't know where these midpoints are, but I just want to get an idea of what this is going to look like. F is the midpoint of BC, and G is the midpoint of AC. Okay, so I have my 3 midpoints. So I need to do the midpoint formula 3 times in order to find the coordinates of E, F, and G. So I have E, F, and G. That's what I'm trying to find. Okay, great. So let's do the midpoint formula. So first, my midpoint formula is, I'm going to do the whole thing in this green color. I like it. Midpoint formula is X mid equals X E endpoint plus X endpoint over 2. Y midpoint is Y endpoint plus Y endpoint over 2. So the first one I'm going to calculate is E. And the endpoints of E, the endpoints of the line are A and B. Oops. Are A and B. So I'm going to use A and B in my equation. So I have X midpoint equals X endpoint is 2 plus X endpoint is 4 over 2. Y midpoint is Y endpoint 1 plus Y endpoint 8 over 2. And I get 2 plus 4 is 6 over 2 is 3. 1 plus 8 is 9 over 2 is 4.5. And I get 3, E equals 3, comma 4.5. Does that make sense in the picture? Let's see. 1, 2, 3, 1, 2, 3, 4. This is hand drawn, but I think that makes sense. Okay, great. So we're going to do the same thing for the point F. All right, so I have X midpoint equals X endpoint plus X endpoint over 2. Y midpoint equals Y endpoint plus Y endpoint over 2. And I'm doing it with B, C, because I want to find F. So I'm doing it with B and C. Okay, so I have X midpoint equals X endpoint 4 plus X endpoint 6 over 2. Y midpoint equals Y endpoint 8 plus Y endpoint negative 2 all over 2. I have 8 minus 2 is 6 divided by 2. Y equals 3. I have 4 plus 6 is 10 divided by 2 equals 5. I have F equals 5, 3. Does that make sense? 1, 2, 3, 4, 5. 1, 2, 3. Yeah, it's hand drawn, so good enough. All right, so now we are going to do this with G, our third and final point. And for this one, we're going to be using, let's see, G is the midpoint of A and C, so I'm going to be using A and C as my two coordinates. So I have x midpoint equals x endpoint 2 plus x endpoint 6 over 2. Then I have my y midpoint equals y endpoint 1 plus y endpoint negative 2 all over 2. And let's see, I get 2 plus 6 over 2 gives me 4. 1 minus 2 over 2 gives me negative 0.5. And this is my coordinate for G. So G is 4. Negative 0.5. All right. So we have answered the second part B, which was find the coordinates of the midpoints of each side of the triangle and write them, which we did. Now let's move on to the next part. So the next part tells us to connect the midpoints EF, FG, and GE. Okay, so I connected the midpoints. The segments that connect the midpoints are called mid-segments. Okay, so these are mid-segments. Okay, great. Good to know. Those are called mid-segments. Oh, no. I erased my thing. Okay, so we connected these. I showed what mid-segments are. Now we have to find the lengths of the three mid-segments. So we want to find the lengths of EF, FG, and GE. Okay. Well, let's do it. I have E. I'm just going to put it over here so it's out of the way. So what do we know when it says length in the question? It says length. Find the lengths of the three mid-segments. Length is always distance formula, right? So I'm going to erase the question so we have some more space. I'm going to set up an area where I can calculate the distance of EF, FG, and GE. Okay, so first I'm going to write my coordinates. I have E is 3, 4.5, and then F is 5, 3. Now over here I have F is 5, 3, G is 4, negative 0.5. Okay, I have no room. Okay, and then GE is going to be G, 4, negative 0.5. E is 3, 4.5. Okay, so the first thing we do when we're setting up distance formulas, we do the equation. Distance equals the square root x2 minus x1 squared plus y2 minus y1 squared. So I'm going to plug in my values. Let's say this is x1, x2, x1, y1, and x2, y2 down here. So my x2 is going to be 5. My x1 is 3. This is squared plus y2 is going to be 3 minus y1, which is 4.5 squared. Distance of EF is going to equal the square root of 2 squared plus 1.5 squared. Distance equals square root of 4 plus 2.25. Distance equals the square root of 6.25. Distance equals 2.5. So the distance of EF is 2.5 units. The distance right here of EF, 2.5 units. Okay, great. So FG, we're going to do the same thing that we did with EF. Distance equals the square root of x2 minus x1. It's hard to write small with this thing. plus y2 minus y1 squared. Distance equals 4 minus 5 squared plus negative 0.5 minus 3 squared. Distance equals the square root of negative 1 squared plus negative 3.5 squared. The square root of 1 plus 12.5 gives us 13.25. We get distance equals 3.64. The distance of FG is going to be 3.64. Hold on, this is messy. Equals 3.64 units. And the last one we have to do is GE. We have distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We have distance equals the square root of 3 minus 4 squared plus 4.5. This thing is being annoying. 4.5 plus 0.5 squared. 4.5 plus 0.5 gives me 5. So I have negative 1 squared, which is going to give me 1. So I have distance equals the square root of 1 plus 25. Distance equals rad 26. Distance equals, the square root of 26 is 5.099. I'm going to round that to 5.10. Equals 5.10 units. All right, so we found the lengths of the three mid-segments, EF, FG, and GE. And now the last thing that we have to do is, what is the connection between the median and the side that is in front of it? Okay, so the medians are EFG, and E, the lines that we just found earlier. Okay, so here are the medians, E, F, and G. All right, so it's asking us to find what is the connection between the median and the side that is in front of it. So if we're looking at, hold on, let me get a different color. If we're looking at EF, we're trying to look at the side that is in front of it or across from it. So we're looking at the relationship between EF and AC. So EF is, what is the length of EF? Right down here, okay, so it's 2.5. And the length of AC is 5 units. So we know that 2.5 is twice, when you multiply 2.5 by 2, you get 5. So EF is going to be half of AC. Let's go over that with the other sides too. Okay, so median FG right here, and then we're comparing it to the side that's across from it, so AB. FG is 3.64 units, and AB is 7.28 units. Conveniently, if you multiplied 3.64 times 2, you would get 7.28. So FG is half of AB. And the same thing goes for the other median, the last median that we had to find, which was GE. So GE is right here. We're looking at the side that's across from GE, which is BC. The measure of GE is 5.1 units. The measure of BC is 10.19 units. If you multiply 5.1 times G, you get 10.19. So GE is half of BC. And now we have uncovered a theorem in which mid-segments are half the measure of the line they are opposite from.